Okay, so today I want to explore NeoPixels and the Rotary encoder, and as I rotate it around, the content of the NeoPixel ring changes. I have a few different versions, few different themes. If I press the knob, this is the first theme, simply filling the ring with a white color. The second theme is going from blue all the way to the red, which might be used for something like AC or heating. And the last theme is actually also going from red to blue, but this time going over all the rainbow colors. So today I will show you how to do that using the NeoPixel ring, the Rotary encoder module and the Arduino UNO, which is hidden behind this breadboard shield. And it's a very simple project, but I have to start somewhere before I turn this into a custom PCB. By the way, talking about the custom PCBs, if you need one, you can use PCBWay, and if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping, and that's because PCBWay is a sponsor of today's video. And even if you don't need PCBs, you can still get services like 3D printing or CNC machining. So thank you PCBWay, and let's get back to our project. And let's not start with the real Arduino, but with the simulated Arduino that's running inside your browser, because that's exactly what Walkway is for. I can create a new project using the Arduino UNO, and I can even add the NeoPixel ring. Now there is one problem with this one, because if I click the UNO, I can click the question mark icon and open the documentation. I cannot do that for the NeoPixel ring, there is no documentation inside the Walkway. But if I just Google search for the NeoPixel in Walkway, I can for example find this sketch, which is lighting up those individual LEDs, and I think that we can copy bits and pieces from this sketch into our sketch. First of all, we need the library, so I'll copy the Adafruit and the NeoPixel library into our sketch. Then I want to define the data input pin and the number of pixels. I'll copy both defines into our code as well. And I want to initialize the NeoPixel string with this line, so just copy this and paste it. Inside the setup function, we want to call the begin function, which is required, so paste it inside the setup function. And then inside the loop, I will actually copy more lines and then delete some of those. I want to clear all the pixels first, and I do want to go over every single pixel, but I don't want to show it until I set all the pixels, so I'll just move it outside and get rid of the delay. And maybe the color that I want to show is white, which will be 255 for red, green and blue channels, and this should be a good start. Now the pin NeoPixel is set to pin number 4, I will probably use pin number 6 for no reason at all. And let's actually connect it, so ground will go to ground on the Arduino UNO, VCC will go to 5 volts on the Arduino UNO, and the data in we've just set to pin number 6, so connect the data in to the digital pin number 6, which is up here. And since my NeoPixel ring has 16 pixels, I will change this number of pixels to 16, and if I count those individual pixels in here, I believe there are also 16 pixels, but if that's not the case, I can go to the diagram.json file and change number of pixels to a different value, for example 24, or maybe just 1, but again in my case I have 16 of those. Which means that all that's needed is to restart the simulation, and we will see the error message because we haven't included the library in the project, so I'll click the install Adafruit library for the project. I can as well go to the library manager, click the plus icon and type in the library name in here, and then click the restart simulation button one more time. And it might be hard to notice any difference, but now all the NeoPixels are shining, having the white color. So let's actually try that on the real Arduino by copying the code into clipboard. Open the Arduino IDE and paste the code in here. Now if you have never used the Adafruit NeoPixel library, you have to go to the libraries, search for the Adafruit NeoPixel and click the install button. Then make sure that the Arduino UNO board is being selected either from here or from this drop down menu, and click the upload button. Now I have quite a lot of different NeoPixel rings. The main difference is the diameter and the number of pixels. I will use this one, which has 16 pixels that are quite tightly spaced. But for example, this ring also has 16 pixels. For many of those rings, you have to manually solder the wires on the backside of the PCB. But if you don't like soldering, I have also some NeoPixel rings from DF Robot, which has those connectors pre-soldered. So you have quite a lot of rings to choose from. Now for connecting the NeoPixel to the Arduino UNO board, it is advised to do that while the Arduino is not connected to power, so disconnect the Arduino from the USB port. Then connect the ground to ground, the VCC to 5 volts and the data into pin number 6. On those NeoPixel rings, you will usually also find the data out pin, which we will not connect, that's only if you want to connect multiple modules together. And so now when I connect the Arduino board to the USB power supply, the NeoPixel ring is shining and it's extremely bright. It's actually so bright that it's hurting my eyes, so let me disconnect it and think about how to fix it. And we can go back into the walk with simulation and change the color from pure white to maybe some grayish color, for example 50-50-50. The problem with this approach is if I restart the simulation now, it's very hard to see anything shining. So what I will do instead is I will set the color and then I will call the NeoPixel.setBrightness function that will lower the brightness for all the pixels, which means that what I can do in here is to just comment out this function for the walk with simulation. So we will still see pure white LED ring in here, and then I can copy this and paste it into the Arduino IDE, and in here make sure to uncomment this function and upload it to the Arduino UNO again. And now the brightness is much more reasonable. So now we know how to set all the pixels to the white color. Let's see if we can update the sketch in a way that will show a gradient from one color to a second color, for example from red to blue or from blue to red, like I've showed you in the beginning of the video. And if we want to blend between two colors, we need to define those colors, so create new variables. That will be the byte array. Let's call the first one color blue RGB, and we need 3 channels for red, green and blue. And there will be nothing in red, green, but everything in blue. And let's create a second color that will be color red. And in this case 255 will be in the red color and no color in green and blue channels. And I will create one more variable and it will be color blend RGB, and we don't need to set this color because I will calculate it later on. And by later on I of course mean right now. I will create a custom function that will not return anything, and let's call this blend colors, and I need to provide few parameters. The first one will be a byte array that will be called color start, that will be the starting color. Then I need a second parameter that will be the color end. I need a color blended that will store the blended color, and I need to know how much I want to blend between the start color and the end color. So let's have one more parameter called percentage, and that should be fine. So I'll create our function. The blended color will be calculated as a mix between the start color and the end color. So let's just say that the blended color is the start color plus some fraction of the difference between those two, so color end minus the color start. And I want to put this inside a bracket multiplied by the percentage, but I want the percentage value to go between 0 and 100, so I will just divide it by 100 and maybe a few more brackets just to make sure that it's calculated in the right order. And since we are working with arrays, I need to put this inside a for loop, so I'll say for integer I equals 0, while the I is smaller than 3, I will increase the I by 1, and then I will use this I variable inside those arrays, so I, and also here and here, do some formatting. And there is one more thing that's quite important. Now what we are doing is that we are changing the color end minus color start, and those are both byte variables. And on Arduino, this goes between 0 and 255, which means it will be impossible to have negative values, which means that we will most likely see some strange results. So what I will do, I will just cast this to float value, so convert everything to float value instead. I can probably use integer as well. And when everything is calculated, I will round this to the integer value, actually the byte value. Hopefully it will still fit. So this is our final function, and let's try to use it in our loop function. Let's just comment out setting the pixels to white for now and call our blend colors function. The first color will be color blue. The second color will be color red. We want to store the color in the color blend RGB. And let's for example set the percentage to 0% and then use the NeoPixel.setPixelColor of the pixel to be the color blend RGB, but we need the RGB individual channels, so it will be the RGB of the first channel, channel number 0, that will be the red channel, then the channel number 1 will be the green channel, and channel number 2 will be the blue channel. And if I restart the simulation, hopefully there will be no errors, and we can see a shining blue color. And that's an expected result because we are setting the percentage value to 0, so only taking the blue color. If I change it all the way to 100%, we should see the red color, which seems to be the case. And if I set this to 50%, we should see a mix between the blue color and the red color, so some kind of a violet color. But we don't want to have all those pixels set to the same color, so instead of using the hard-coded percentage value, let's use the value based on the pixel value, which is the counter inside loop function, and the pixel goes between 0 and number of pixels, which is 16, and we want it to go between 0 and 100%, so I'll just multiply it by the 100 divided by the number of pixels. But since the pixel will never reach the number of pixels, I have to subtract 1 and maybe put this inside the brackets, as well as this one, like so. And if I restart the simulation now, I should see the gradient going from blue all the way to red. So let's try that on the real Arduino. And that should be as simple as copying the code into the Arduino IDE. Make sure to uncomment the last line for setting the brightness and then upload it to the real Arduino. And in a few seconds, you should see the gradient being displayed on the NeoPixel ring. And while it looks nice, I think it's time to make it more dynamic by adding a rotary encoder, which looks something like this. And the good news is that it's also supported on the Walkway sketch, so I can add the rotary encoder into our sketch. And I can as well click the question mark icon to open the documentation, because there are some examples down here showing how you can read the rotation in the loop function or by using interrupts, as well as reading the button state. But this time I will probably use some kind of library, because I have found a library called Encoder, which is this one, and I was actually able to get a better results using this library instead. So what I will do is I will jump to our project, go to Library Manager and add the encoder library. That's this one. And then inside the encoder library, I will open examples, basic, and open the basic.ino. Make sure to, of course, include the encoder.h file into our project, just like that. And then we want to initialize our encoder, and it says it's the best if we use pins with interrupts. If I open another documentation, you can see that for our used board, which is the Arduino UNO, we can use digital pins 2 and 3 for interrupts. So I'll use those two. So I'll just copy this code into our sketch, maybe paste it up here and use pins 2 and 3. And actually, maybe just to see if everything works, I will copy the rest of the code into our sketch as well. So opening the serial connection inside the setup function, and then inside our loop, we will just print the value. So this old position should be outside of our loop. This code will just make sure to print the position if we rotate the rotary encoder. Let me just move it closer to the NeoPixel ring and then connect the clock to be pin number 2. So as we've defined, the pin number 2 up here. And then the DT to pin number 3. And of course, plus should go to VCC to 5 volts and ground should go to ground. I will not connect the middle pin, which is for button, because we are not using the button for now. And I will restart the simulation and see if we can read the value of the rotary encoder. And you can click those arrows to rotate the encoder around, or you can click the right arrow on the keyboard or the left arrow on the keyboard, and that will rotate this as well. And as you can see down here, we are getting some values, the position of the rotary encoder, so it seems to be working just fine. Which means that we don't need to print this value, so I'll just delete this serial begin and print line functions, as well as those lines. I just need to read the new value, and for that I will create a few more variables. The first one will be of type integer, and let's call this encoder value old, and set it to some value, and then encoder value new. And I want to have one more value that will be the percentage value, that will go between 0 and 100%. And what I want to do in our main loop is to read the value first, and I will say that the encoder value new equals the read function of the rotary encoder, and then I will have the if statement saying that if the new value doesn't equal the old value, in that case I want to update the percentage value, and I want to update it in a way that I will add the difference between the new value and the old value. So new value minus the old value, put those inside brackets, and then after everything is calculated, I will update the old value saying that the old value equals the new value. But there is one more thing that I want to update, because the percentage value should only go between values 0 and 100%. So I'll constrain it using the constrain function, and I will constrain it between 0 and 100. So now every time I update the value, it will not go outside the 0 to 100 range. The only thing that's left to do at this point is to update the NeoPixel ring based on our rotary encoder value. So when we draw all the pixels, when we update all the pixels, I will add one more if statement, and I want to compare this pixel times 100 divided by number of pixels value, and say that if this value is smaller than our percentage value, and of course put everything inside brackets, only then we will set the pixel. So let's restart the simulation and see what happens. And by default nothing is visible, which kind of makes sense, because by default our percentage value is set to 0%, but as I start rotating the rotary encoder, you can see that the NeoPixel ring is filling slowly. Now what's happening is that I'm pressing this down arrow, this counterclockwise arrow, but the NeoPixel ring is actually filling in the opposite direction, being the clockwise direction. So what I will do in here is I will change the code in a way that I will not add this new value, but I will actually subtract this value. And if I restart the simulation now, hopefully the rotation of the rotary encoder as well as the filling of the NeoPixel ring will be in sync, which seems to be the case. So I think that now we can test this on the real Arduino. Let's copy the code into the clipboard and paste it into the Arduino IDE. Don't forget to uncomment the last line for setting the brightness. And since we are now also using the encoder library, I have to go to libraries and make sure that the encoder library is being installed, which seems to be true in my case. So just hit the upload button to upload it to the Arduino. Now connecting both the rotary encoder module and the NeoPixel ring to the same Arduino board might be tricky, because there is only one 5V pin on the Arduino UNO, and that's why I'm using this breadboard shield. I will connect both modules in the same way as inside our walk with sketch. Restart the Arduino just to make sure that it works. And now when I start rotating the rotary encoder, the NeoPixel ring should be filling with colors going from blue all the way to red. So it seems like that everything is working as expected. And when I reach the maximum value, I can keep rotating the rotary encoder. It should still keep the value at 100%, and as soon as I turn it into the opposite direction, it should decrease the value. So I think that at this point we can try the last theme, which will be the rainbow effect. And doing that is actually quite simple if we use the hue saturation value or hue saturation brightness color space, which is nicely described in this Adafruit documentation. So instead of using the RGB color space, we will use the hue saturation value, or sometimes referred as a hue saturation brightness. The only problem is that the hue value in Adafruit library is defined as a 16-bit number, while the saturation is 8-bit and the value is 8-bit, and that might complicate our sketch a little bit. So what I will do instead is I will still treat the hue value as only 8-bit number, meaning only going from 0 to 255, and then when I will do the conversion from the HSL to RGB, I will simply multiply this value by 255, which should give me the 16-bit value as required. Let me open this image and show you what's going on. So right now we are interpolating between the blue color and the red color, and we are just trying to find the shortest path between those two colors. What we will do now is we will still interpolate between those two colors, but instead of going this way, we will go all the way around the circle, which means that we will get all those yellows, greens and blues. Or if we decide to go over the other side of the circle, we will still get the gradient from blue to red, but now having those in between violet colors. The first step is to define few more variables, few more colors in the HSV color space. I'll copy this and rename it to HSV for the blue, red and the blend color, although we probably don't need a separate blend color. And for both red and blue, we need the highest saturation, so 255 for saturation, and highest brightness, so 255 for brightness. Now, if I look at this image, the hue for the red is either 0 or 65535. I will start with the 0. For our red color, it will be 0, and then for blue, it will be 65536 divided by 3 times 2, which is around this value. But again, we are not using 16-bit value, only 8-bit value, so I will divide it by 256, which is around 170. So for the blue color, in the HSV color space, it will be 170 for the hue. Let's scroll down into our main loop function and let's just rename it to blend two colors in RGB color space. Comment it out for now and then copy it one more time. But this time we want to blend colors in HSV color space, which means that we will use the color blue HSV, color red HSV, also color blend HSV, and then setting the color of the NeoPixel to be color blend HSV for 3 channels, like so, but the NeoPixel color expects the RGB color, which means that we have to use a different function. It's called color HSV, so I'll copy this function and use it instead of color function, so color HSV. And we've already said that the hue should be a 16-bit color, which means that I have to multiply it by 256. And since this is a byte variable, we have to cast it to a different type, for example, long or unsigned integer, just to make sure that we have enough space for this big value. And that should be probably enough, so let's try to restart the simulation. And once this is up and running and I rotated the rotary encoder, we should see the gradient going from blue over greens and yellows all the way to red, which again mimics this image going from blue to green to yellow to red. And that's because we defined the red as the hue of being 0. If we instead define the red as the maximum value as the hue of 65535, we will go around the circle in this direction. So let's actually try that as well. So for our color red HSV function, the maximum value will be 255. And if I restart it now and rotate the rotary encoder, we see the gradient from the other side of the circle, again going from blue all the way to red, but having those in between pink values. I will revert this back to 0 because I like it better this way, and let's try that on the real Arduino. And you should already know the steps, so copy this code into the clipboard, paste this into the Arduino IDE, uncomment the last line for setting the brightness, and upload it to the real Arduino. And sure enough, same as inside the walk with sketch, by increasing the value we should see the rainbow effect. But you can do more with the encoder than just the rotation. There is also a button included, so you can click it, and let's use this button to switch between those 3 themes which we have just created. The button pin is the middle one, and I will connect it to any 3 digital pin, for example pin number 4, and then jump back to the walk with simulation. And in here, connect the button pin in the same way. So the button pin should be connected to pin number 4. And then I will select the rotary encoder and open the documentation, because there should be a code for reading the button value, which is down here. So first we define the button pin, which is also pin number 4. So I'll copy this into our sketch and paste the define for the button pin. Then inside the setup, we need to set the button pin to be input pull up. So jump to the setup function and set the button pin to be input pull up. And then finally inside the loop, we will read the state of this pin of the button. And if it's low, it means it's being pressed. So inside the loop, I will read the state of the button. And if it's low, I will switch the mode. And of course, for that, I need some kind of new variable. So I'll create a new variable of type integer and call this mode and set it to 0. And then when the button is being pressed, I will just increase the mode by 1. And since I have 3 modes, I will say that if the mode is bigger than 2, in that case, I will set it back to 0. And then I will use the mode down here for every single pixel, saying if the mode equals 0, in that case, we want to draw white pixels. And let me actually set it to 0. If the mode equals 1, in that case, we will blend between blue and red in RGB. And finally, if the mode equals 2, we will blend between blue and red in HSV color space. So with everything prepared like that, we can just move the code around. So this is all white pixels. The next part is blending in the RGB color space. Uncomment this, of course. And finally blending in the HSV color space. That will be for mode number 2. One neat thing in Walkway is you can right click and select format document. That should fix all the indentation problems. And I just realized that this if statement should be above everything else. So I'll just paste the if up here and do the formatting once more. Before restarting the simulation, I will do one more thing, and that's after setting the mode. If we change the mode, I will add a small delay, for example half a second, because otherwise it will be switching between those modes quite rapidly. So let's restart the simulation and see what happens. By default, the mode should be set to 0, so if I rotate the rotary encoder, all the pixels will be filling with 0. If I press the button, it will switch to blue to red, and if I press it again, it should switch to rainbow colors. So it seems to be working just fine. Let's run this on the real Arduino. That means copying the code into the clipboard, pasting it into the Arduino IDE. Don't forget to uncomment the last line for setting the brightness and upload it to the Arduino UNO. And with the sketch uploaded, we can now rotate the rotary encoder to change the value on the NeoPixel ring. And we can also press the rotary encoder to change the theme from white to the blue to red in the RGB color space, and to the last theme, which is the blue to red in the HSV color space. And hopefully this video gave you some ideas how you can spice up your project using the NeoPixel ring. I would like to explore more in the future videos, maybe find a ring with more LEDs or maybe create one with smaller LEDs. Since all the NeoPixel rings that I have found uses those 50/50 NeoPixel LEDs, which are quite big. And you can get the NeoPixel ring in much smaller footprint. For example, the one that's on my finger and it's almost invisible. That's a 15/15 footprint. And again, I would like to use it to create my own version of the NeoPixel ring, or at least try that. Anyway, that's something for the next time. For now, if you have any questions, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.